All right, so organic chemistry is all about making large molecules. And I said we're going to start with the basic aspects of this. It is called, well, we're going to start with, this is organic chemistry, and we're going to start with hydrocarbons. Hydrocarbons. Carbons. All right. Now, hydrocarbons are based on two elements, and these elements have such properties that we can build huge molecules. And it's not like Lego, but for grown-ups who are scientists. So this is the fun part. Now, the two elements it's based on is in the name. Hydrogen, let me tee that out. Hydrogen and carbon. Now, I've got friends who work within organic chemistry, and this is literally the kind of fun stuff they do. They use huge machines to analyze molecules and things like that. Now, carbon is the backbone, the basis for where we have hydrocarbons, carbohydrates, organic molecules, biochemistry, and everything. And carbon, I put periodic table there. I love this by Mr. Hutton. And it's group 4. Group 4 means, and I hope you remember, 4 outer electrons, and it makes 4 bonds. If you don't remember, it doesn't matter. I've just told you again. And the way to draw it is I've got a carbon atom here. I have 1, 2, 3, 4 bonds. Hydrogen is H11, and it only makes, it's got 1 outer electron, it makes 1 bond. So we can like attach them all together like Lego. And what we can do is look at how to attach them. So the key things that I've written up here that you need to know. Carbon atoms form 4 bonds, and that allows us to make chains and rings. Hydrogen makes 1 bond. Okay? We find them everywhere. Fuels, medicine, plastics, in here, in yourself. And the simplest one to look at is alkanes. And right now, don't worry about the names, but we're going to practice them. And we're going to look at anes. Anes tells us what the structure is going to be like, and these are the simplest ones. And I'm going to show you, and I'm going to do a bit of maths, because maths is brilliant. So if I've got 1 carbon, I can attach 4 hydrogens around the outside. Okay, 1, 2, 3, 4. And you look at the hydrogen, it's got 1 bond, 1 bond, 1 bond, 1 bond to each hydrogen. If you look at the carbon, let me change colour, darlings. I'm going to go to what colour should I do? Ooh, an interesting green. Carbon's got 1 bond, 2 bonds, 3 bonds, 4 bonds. So we're all happy. Okay? This is the simplest of the alkanes. So the group of molecules we are looking at are alkanes. And this is the simplest. And it's called methane. And you have to remember that a hydrocarbon with 1 carbon starts with the term meth. This is an alkane, so it's methane. All right, now, this is how we can string them together. We can now go, ooh, looky. What colour is that? I'm going to go back to like kind of bluish colour. This is 1 carbon. So now I can string 2 carbons together like this. Dun, dun, da, 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 da. And if I count very, very carefully on each carbon, you'll see me. 1, 2, 3, 4 around my first carbon. My second carbon here has got 1, 2. That counts. 3, 4. And this around the outside is going to have the hydrogens. And if you look very carefully, each one of these bonds, and they must be attached to something. It can't float around doing nothing. Right? Now this is a 2-carboned alkane, and this is called ethane. All right? And the way to look at how we name them, I put them here. Right? If it's got 2, where's my 1 carbon gone? Oh, there we are. If it's got 1 carbon, it starts as methane. Right? Ethane with 2 carbons, propane with 3, 4 is butane, and I kind of remember it as PB. Me made of lead like a superhero. 1, 2, 3, 4. Me PB. All right. Now, the next thing is, what? That looks a bit weird. Not so much. It's a cheeky way of writing these out without drawing the whole thing out. So if I look at this, we carbon, then hydrogen. Well, how many carbons have we got here? Well, we've got 1. Dun, dun, dun. Right, fine, I'm happy. But we do like massy thing, we never write 1, so we'll just leave it C because that's 1 carbon. Hydrogen's 1, 2, 3, 4. Da, 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 da. Boom. This one, we'll do the same, CH. Well, how many carbons have we got this time? 2. 2 here. How many hydrogens? 1, 2, 3, 4, 5, 6. C2H6. There's a pattern to these numbers. And if you haven't done number sequences yet in maths, it really doesn't matter. I shall teach you them very quickly to do with alkanes. All right, so N means the number of carbons. So we're going to have a look at 3 carbons. 1, 2, 3. So N is 3. N equals the number of carbons. The number of carbons. Oh dear, I didn't type that very well, did I? Number of carbons. All right, so here we've got 3 carbons. So, aha, N is equal to 3. So I'm going to go, let's rub that out and change to 3. H. 2N means 2 times N. So I've got 2 times N, which we know is 3, plus 2. All right, so the only thing you'll change is that N to 3. 2 times 3 is 6, add 2 is 8. So we end up with C3H8. But do we? What is this cheekiness that they're doing? Does it really add up to 8? Well, only one way until I'll draw it out. Dun, 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 dun. And I've got hydrogens here, here, here. Oh God, it's so long. I'm going to take drawing that out. So I'm just going to take it and paste all this in. It saves me drawing all those hydrogens. Anyway, so let's look at it. This is 1, 2, 3 carbons, C3. Let's start from here. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, H8. So this is an easy way of writing this without drawing it out. This is an easy mathematical way of really doing tough ones in terms of, well, how many hydrogens is there on a carbon molecule, an alkane with 10 carbons? If N is 10, CN, H, 2N plus 2. I'm going to draw this out because it's properly. So what you do is you go, aha, N equals 10. All right, so let me move that. Let's just let me move that down to the bottom. N is 10. All right. So this part here means 2 times N. So 2N means 2 times N plus 2. I'm just going to color code it. What I mean by color code is you are not changing the 2. That never changes. And you are not changing that 2. It stays the same. You do not change that times and you do not change that add. The only thing you're going to change is the N because you changed it to 10. So what we do is we write this out in 2 times. That hasn't changed. I've kept the same color. The N is 10 because we're looking at a 10 carbon molecule times 10. Let's go back to blue. Plus 2. Bid mass or bod mass, whatever you call it in maths, 2 times 10 is 20. Add 2. 22. So the number of hydrogens is 22. And I am not drawing I'm not drawing it out here. So do you know what? Let's see. Image of a 10 carbon alkane. I can't hear you, darling. Oh, dear. Thank you for that. Thanks, Alex, darling. I didn't know they were in there. Right, so C10H22. Okay, so I'm not going to draw this. I'm really not. It's going to take too long. So what you can do is 1, 2, 3, 4, 5. That's not enough. Oh. So once you've done that, we can look at different tables. Here's an interesting table. So that, without me drawing it out and giving you a really nice example, here we go. Okay. So you can see that calculation I did there. All right. This calculation I see here, C10H. Look, it works. It's like magic. All right. And so that's an explanation of everything you need to do. You've got your first set of questions here. All right. Now, for everyone who is a little bit late, I am going to stop this recording. It's a 10-minute.